Hello everyone, this is the part 2 of the exam 3 review. So in this part we're going to go over the multiple choice questions. We have ran 11 of those, I think. Let me double check. Yeah, we have 10 of those. So first and anything, let's go over question 1. In question 1, we have a comparison with an identity. We have cosine square of 6 theta minus sine square of 6 theta, and we want to know what that simplifies to. So if you remember, this is strikingly familiar to a formula that we have available in the formula sheet, which is cosine square of x minus sine square of x is equals to the cosine of 2x. So if we replace that x with 6 theta, then what we're going to get is that cosine square of 6 theta minus sine square of 6 theta is cosine of 12 theta, which is option C. Okay. And so that's question number 1. Now for question number 2, we have information in what is the cosine of 2x, but then we want to calculate 1 over 2 cosine square of x minus 1. If that sounds familiar down below, is because cosine of 2x is also 2 cosine square of x minus 1. That is one of the identities that relates cosine of 2x to the cosine of x. So if we have the information that this is 3 over 5, what we're essentially saying is, hey, 2 cosine square of x minus 1 is 3 over 5. So 1 over 2 cosine of x, cosine square of x minus 1 is going to be flipping this around, and it's going to be 5 over 3. Okay, and so that'd be answer B here. Now moving on, question number 3 says we have sine of x plus cosine of x over cosine square of x, and that can be rewritten as, and we have certain options. Now, the key thing here is that we're trying to prove an identity. And of course, we're going to be departing from this side. Since we need to do some kind of operations, the easiest thing that we can do here is just break apart this fraction into pieces. This is sine of x over cosine square of x plus cosine of x over cosine square of x. Remember that with identities, we're always coming from one side to the other. So we're trying to see what is this going to produce. So now, at this point, notice that sine over cosine square is not any particular identity. But we can break the cosine square. We can break it as cosine of x times cosine of x. And if we do that, that's going to have an effect on both of the fractions. First in here, I can cancel one of the cosines. And so that's going to leave me with 1 over cosine of x over here. And for this one, I can kind of separate this into fractions. Sine over cosine times 1 over cosine of x. Notice that if you multiply back, you get this original thing. So that's how we know that we're in the right track. Now, at this point, we can actually transform this in terms of tangent and secant. That seems to be what is involved. So notice that this is tangent of x times secant of x plus secant of x, which is option A. Okay. Some of this is easy to disregard initially. Use, like, for example, tangent and tangent by secant, because you see that this is a plus that you're not going to be able to get rid easily. So that one could be one way of identifying very quickly that that was going not to be the answer. But between A and D, it was kind of hard to choose because they still have the plus and they have things in terms of secant and tangent. So here we're actually forced to get from one side to the other. Now let's check question number 4. In here, we're trying to find out what is the tangent of 210. So there's two ways that you can actually go ahead and do this. One of them is, of course, use your calculator. So if you use your calculator, you're going to find out that this is 0.577. More or less around that. And so you will have to compare with the options that you have in here and get to know which one of this correspond to this 0.577. Because this is a positive option, there's only two positive options that match up, square root of 3 over 3 and square root of 3. And you can immediately disregard A, C, and E. Now, then you get to test those two values, and you're going to find out that it is actually B. But if you want to find out this from the trigonometry point of view, you can also see this as tangent of 210 degrees at sine of 210 degrees over cosine of 210 degrees. But this is easier to see if we do it with the reference angle. So in here, 210 is over here, and we're trying to find the value for this big angle. But instead of finding that big angle, I can just go ahead and do this one. This is small one here. And how do you calculate that one? Well, that's going to be 210 minus 180, and so that'll be 30 degrees. But we are on the third quadrant. So in third quadrant, the sine is and the sine and cosine, they're both negative. So you can see that this is going to be minus sine of 30 degrees and minus cosine of 30 degrees. And so at this point, if you remember your geometry of special angles, then you're going to know that this is 1/2 now, and this is a square root of 3 over 2. So if you cancel the 2's, this is 1 over square root of 3. And then you can multiply by a square root of 3 up and down, and that will give you square root of 3 over 3, which is, of course, option B. Now, for number 5, we have information in sine and cosine, right? We have sine of theta is minus 3 over 5, and cosine of theta is minus 4 over 5, and they're asking me about the value of sine of 2 theta. And here, this one is easy because I just need to state the formula of sine of 2 theta. The formula of sine of 2 theta is 2 sine of theta cosine of theta. And because I already have the values of sine and cosine, I just need to replace them. This is 2 minus 3 over 5 by sine, and cosine is minus 4 over 5. And so here, 3 times 4 is 12, by 2 is 24, and over 25. So this will be D. Now on the next one, we also have something akin to an identity. So before proceeding, I'm going to get some space here in the board. All right, so we want to simplify expression for secant minus secant of x minus cosine of x. But secant of x can be seen as 1 minus cosine of x minus cosine of x. I can see this as two fractions. This is cosine of x over 1. And notice that we can use the sum of rationals, which is p over q plus or minus r over s, being p times s plus or minus q times r over q times s. So in this case, that will mean that it's 1 by 1 minus cosine times cosine, which is cosine square, over cosine times 1, which is cosine. Now we can see 1 minus cosine square as sine square by the main trigonometric identity. And so sine over cosine square is something that we cannot very easily transform, so we can just split it. Split this as sine times sine, and I'm going to leave the cosine over just one of them. And so as you can see, this is tangent of x times sine of x, which is option D. Now, number 7 is very similar to what we did in number 5. We are going to have to come from what is an option for cosine of 2x, where I can use the information that I have in terms of the sign. So fortunately, I do have one identity that works with that, which is pretty much cosine of 2x is 1 minus 2 sine square of x. Remember, you have available the formula sheet, so you should be able to find a formula that relates cosine of 2x with just the sine, which is what we have information. We could potentially do it with something else, but this is the easiest way to go around in this case. And now this is 1 minus 2, and then 3 over 4 is square. Of course, we gotta square the result, and this is gonna be 9 over 16. I can convert the 1 into 16 over 16, and this is minus 18 over 16, and this is gonna end up being minus 2 over 16, which is equivalent to minus 1 over 8, which is option D as well here. Now we move to some of the triangles. So the triangles, with the triangle, is very important to have an idea of where is the angle located, and once that we have the angle located, identify what is the opposite and what is the adjacent side. So in these two cases, notice that the angle is in different positionings, and that's going to determine who's the adjacent and who's the opposite. In this scenario, the opposite is y here, and the adjacent is 3. So when they ask me to find out y in terms of theta as a function, notice that because we have opposite over and adjacent, it's very easy to think like, okay, so opposite over adjacent, so pretty much y over 3 is equals to the tangent of theta. So from here, it's very easy to see that y is 3 tangent of theta, and that's going to give us option C. Now, on number 9, it's a little bit different because the angle is in a different position. So notice that here we don't know information about the opposite, but we know about the adjacent, and we know about the hypotenuse. So adjacent and hypotenuse are related by the cosine. So adjacent over hypotenuse are the cosine of theta. But what is this? What is the adjacent? The adjacent is 4, and the hypotenuse is C. Now, I can find out who C is in terms of theta by doing C is equals 4 over cosine of theta. So that pretty much will be 4, and since the cosine is below, I can think of this as 4 secants of theta, and that's going to be option D. Now last, to finish up here the multiple choice, I'm going to find the average rate of change of sine of x over the interval x minus 0.01x. So if you remember the formula of the average rate of change in an interval AB, this pretty much h for a function h of x, of course. This is h of b minus h of a over b minus a. Okay? So what's going on in here is that we are defining who a and b are. A is going to be x minus 0.01, and this is going to be b. And h of x is going to be this one. So I can identify that ratio as sine of x minus sine of x minus 0.01 over x minus 0.01. And if I simplify that, that's sine of x minus sine of x minus 0.01 over the x is going to cancel with the x, and the minus with the minus is plus, so this is 0.01. And so notice that in our answers, this is actually going to be option B. Okay, and that concludes the multiple choice from the exam 3 review.